All right, thanks again for joining today. We are going to have Michael Sinatra talking a little bit about the implementation of MANRS within ESnet and MANRS in general. And he has a couple of demonstrations and things that he's going to show in addition to this content. And we, of course, will make this all available afterwards. So I will turn it over to you, Michael.
Thanks, Jason, and thanks for having me. I am going to talk about not just MANRS, but about implementing MANRS in ESnet. And I do call this the Ingest and Inform series because I really hate lunch and learn as a name. It's what vendors do when they want to sell me something during my lunch hour. So I'm not going to call it lunch and learn. But I think Ingest and Inform is pretty good. It's certainly better than expel and explain. So I'm going to talk about sort of what MANRS is and why we're doing it, and then talk about how we implement some of the stuff in MANRS, especially using automation. So, and hopefully I'll be able to give some demos of some of that information as well. So what is MANRS? It stands for Mutually Agreed Norms for Routing Security. It is a way of creating a community-based organization that is able to coalesce a set of best practices and encourage, maybe not quite coerce, but strongly encourage the consistent adoption of those best practices across the internet. It's designed to both protect the internet from network operators leaking routes or doing things that perhaps won't be that good for the internet. It's also designed to help protect network operators' infrastructure itself. And network operators in this context actually does include universities and university systems, and of course, RNE networks. So you can think of MANRS as something sort of like wearing a mask. Increasingly they are finding that wearing a mask both protects you and the people around you. It prevents you from receiving a high dose of virus if there happen to be viruses in the air. And it also protects the people around you. MANRS works much the same way. It actually protects the rest of the internet from getting spoofed traffic from your network or from getting hijacked prefixes, from allowing people on your network or networks that you peer with to hijack prefixes and spread those hijacks out through the internet. And I did mention, this slide's about a year old actually. The mask part's new, the little icon is new, but the part about herd immunity, that I wrote back in the summer of 2019, so I wasn't thinking pandemic back then, but it actually is a pretty good metaphor. The idea that if you can have enough people implementing best practices against traffic spoofing and against route hijacking, then you can make these kinds of attacks so impotent that people won't consider doing them. And the components of MANRS are the four major actions that are often called. They coalesce around things like prefix filtering or the prevention of the propagation of incorrect routing information through the internet. So that means information that might be originated in my network or with a peer or customer. I'm going to prevent that from being able to propagate through my network and to the rest of the internet. Also, anti-spoofing. So that means that customer sites should only be able to source traffic from their IP address space. They should not be able to pretend that they're sourcing traffic from someone else's IP address space. Coordination and communication, which involves making sure that our contact information is up to date. If someone needs to get in touch with us and say, there's something wrong with your network, you need to fix it really quickly, that we can actually do that action, take that action very, very quickly. And there are particular databases and community ways in which we can do that. And then finally, the route validation and route policy expression component, which we'll get into in greater depth soon. Why are we doing this though? If you're not familiar with what MANRS is trying to do, it might be useful to kind of refresh ourselves on some of the problems we've had in the internet over the past 10 or 12 years. And the big one was this sort of Pakistan telecom misconfiguration. And this looks old, it's 2008, but these sorts of things are still happening. What Pakistan Telecom was trying to do was essentially block YouTube in the Pakistan network, through the country of Pakistan using the Pakistan telecom network. It ended up leaking out by creating a BGP route that was a more specific prefix. It ended up effectively black holing YouTube, but it also re-announced that more specific prefix to the rest of the internet. So about half the internet picked it up by the time we were able to fix what was going on. And it basically black holed YouTube for large parts of the internet. You often find nowadays, even recently, people using devices called route optimizers. Route optimizers are supposedly value-added devices, and whether they're actually value-add, you can kind of decide for yourself. But they're devices that try to provide a more sophisticated heuristic than the routing system can provide for selecting and granularly steering traffic to different service providers. They do this oftentimes by injecting more specific routes into your own routing table, since you are the user of the route optimizer. But it turns out it's all too easy for these route optimized routes to leak into the global internet routing table. And then pretty soon, everyone is trying to get to Google through your network, which often doesn't work. So we still see this happening, you know, as recently as last year, or as about 6 months ago, we saw a big problem with a route optimizer that was being carried by a major service provider and leaking out into the broader internet. In addition, there are a number of intentional hijacks that occur. Those were the unintentional ones, but the intentional hijacks that occur, including a really, really exciting one. You can see I've stolen other people's slides in talking about some of the problems here, but a really good example of somebody hijacking AWS Route 53 in order to basically create a fake DNS service that would redirect the Ethereum, one of the Ethereum wallets, to a fake site that would basically steal cryptocurrency. So this required a lot of moving parts, but it worked because basically being able to hijack DNS gives you a great deal of leverage. And because AWS Route 53 does not support DNSSEC, you actually have the ability to easily fake DNS records in AWS, or for anyone who's using AWS Route 53. So by hijacking these prefixes, they were able to hijack the DNS and then reroute the traffic for my Ether wallet, which is an Ethereum wallet service, to their fake site, which was able to steal cryptocurrency on the order of about $150,000. In addition to route hijacking, there's also the problem of IP address spoofing. You're probably aware of what IP address spoofing is if you have been following any security related news or anything like that, or if you've been involved in trying to deal with a distributed denial of service attack. IP address spoofing is very commonly used in distributed denial of service attacks, and particularly in what are called reflection amplification attacks. Reflection amplification attacks are where you create, particularly with a UDP-based service like DNS, or in some cases NTP or other UDP services, you create a request with a fake source address. The source address is actually the victim that you're trying to attack, and you ask a perfectly innocuous DNS server or some other type of server out there to respond to a query. That query could be a very small query like, I want all the text records for nyu.edu. Once the DNS server responds with all the text records for nyu.edu, that response is usually much larger. And I actually just think an interesting security experiment for someone to do is go to all the EDUs and other big organizations, look for all the text records they have at their top level DNS. It often has things like what services they're using. You can see they're using DocuSign, you can see they're using Google, and they've got these little cryptographic hashes that basically authorize them to use these services. But these text records also provide a large multi-byte response to a very small query, and that can create a reflection amplification attack. If you spoof the source address of that query, the DNS server will very conveniently send that response back to the originator, well, the fake originator, the spoofed source address, which is really just a victim. So reflection amplification attacks do require DNS, or they require IP spoofing to be allowed through the internet. And so for this reason, protecting the internet against IP address spoofing is very important, but it's also not particularly easy. This is just a general statistic on the routing system. And this is what MANRS, who is doing MANRS in the R&D community and with some of our partners. Now, again, when I talk about the different controls we put on, and I'll talk more about spoof prevention and also about route hijack prevention, but it does require implementing the various MANRS requirements. So here you have a set of networks that are actually implementing these requirements. And MANRS website actually has a list of all the participants. So you can see here's an absolutely non-exhaustive list, but these are a lot of our peers. I haven't even included the US universities that are also involved. And I have missed some of the R&E partners, because some of the R&E networks, because those are actually listed under their university names, or the names of the universities that implement them, rather than under the names of the actual network. So for example, Boston University is listed, and I think they're the operator of Northern Crossroads. And so the Northern Crossroads AS number is listed, but I didn't include Northern Crossroads because I didn't include any universities. That would have just made the list too long. A number of our international partners also do MANRS, and some of our cloud partners, I'm surprised that list actually hasn't gotten longer. Right now, it's only officially Microsoft and Google. Sometimes cloud and CDN, because of the way that they handle CDN distribution, there are certain MANRS requirements that are a little harder for them to implement. And then I also talked about ISPs that some of us use, as well as IXPs, the internet exchanges, like Equinix exchanges. And even though AMP6 and DKIX are in other countries like Netherlands and Germany, respectively, they also do a lot of business in the US. There are AMP6 and DKIX locations in the US, and they also participate in MANRS. The requirements for MANRS for IXs are actually different than that for network operators. And I'm only going to go into the MANRS requirements for network operators in this talk. So that's definitely, IXs have a whole set of requirements that are out of scope from what I'm talking about right now. Okay, so some of those MANRS controls. I talked about the kinds of things that happen when routes are hijacked, and also when you allow spoof traffic on your network. And I was saying that anti-spoofing, for example, is kind of tricky. And I'll talk a little bit more about what we actually do in order to prevent that. So in terms of prefix filtering, ESnet has done prefix filtering for a long time. Now, what is prefix filtering? Basically, what it says is that when you have a peering with another entity, like a downstream customer, so for example, if you connect to ESnet, if you're a national lab that connects to ESnet, or if you're a university that connects to Internet 2, or peers with ESnet using LHC1, we will only accept the prefixes, and Internet 2 also will only accept the prefixes that are registered to you either in the IRR system, or you've specifically asked us and requested that we allow. So we have to build up a trust relationship with our customer, but we also build up a relationship with the IRR system. And Michael Lambert talked about the IRR system already. But basically what that means is that we're only going to accept prefixes that you're basically allowed to announce. And because of that, if you try to announce another prefix, like YouTube's prefix, or one of YouTube's prefixes, or AWS Route 53 prefix, we're simply going to reject it. And we're certainly not going to pass that on to the larger internet. In order to implement this, it does mean that we need to have a list of all the prefixes that are supposed to be announced by our customers, and a list of all the prefixes that are supposed to be announced by our peers. The only peers that we don't filter are transit peers. And that's because we accept all routes from transit, and we expect to get the entire internet routing table from our transit providers. So our transit providers are Hurricane Electric and Level 3/CenturyLink. And they announce about 830,000 IPv4 routes to us and about 96 or 97,000, whatever the current number is, IPv6 routes. So that is the full internet routing table. There's no default route in there. It is the entire internet that we're getting from that. So it doesn't make sense to filter based on explicit prefix filtering. What we do for transit instead is we filter for obviously bad prefixes, things like RFC 1918 space, bogons, and also prefixes that are too long. We will not accept /32s or even 29s from peers or upstream providers. We only accept down to /24 for IPv4 and /48 for IPv6. So we're kind of a bit of a hard ass there. Or I should say I am, because I'm the one who kind of pushes that limitation pretty hard. For customers, we will make exceptions to that. So certainly for things like LHC1, or also for customers who are connecting directly to ESnet and need to inject a few longer prefixes, but we don't re-announce those to the internet. In order to implement these controls, we need to do automation. And so we keep the information that we need in various databases, including our own internal database, but also we do reference information that's in public databases. And that includes the IRR system, which again, Michael Lambert talked to you about a few weeks ago in this forum, and also a database called PeeringDB, which I'll show you and talk about a little bit later on when we talk about coordination and communication. In addition, we are going to be implementing, we're in the process of testing RPKI, and we're going to be implementing RPKI origin validation. I talk about some of the technical impediments, but most of those technical impediments are going away now. RPKI origin validation is getting much easier to do. There are still some legal impediments, and I'll gloss over those fairly quickly because we could spend the entire time talking about those if we wanted to. In addition to prefix filtering, there's also anti-spoofing. I point out anti-spoofing is kind of hard because it does mean that not only do you not accept prefixes from someone else's BGP session when they're not supposed to be announcing those prefixes over BGP, but it also means that you filter traffic based on the source address. In other words, the stuff that the prefixes that your customer or your peer have registered to them, there shouldn't be traffic sourced from any other part of the internet other than those prefixes. So the source address of packets coming into your network should only be sourced from the prefixes that that customer owns. Spoofing, doing anti-spoofing on peers is kind of difficult because there is a lot of asymmetry in the internet. So you may get traffic in from different peers when you have the best route out to that peer. But we do apply what are called BCP38 filters. And the BCP38 filtering means for all of your customers, you apply filters on ingress to only allow traffic sourced from the prefix that your customers have registered to them. You only allow that in. So not only do we not allow them to announce prefixes, we don't allow them to source traffic from prefixes that aren't stuff that they already own. We did this for BCP38. We've done for customers since before I got to ESnet in 2011. And for IPv6, I helped implement that in 2014. And we use ACLs for that. It's also possible to use unicast RPF to do that. When I worked at UC Berkeley, for example, we had unicast RPF turned on for every departmental subnet. And we did that back in 2000 or so. It was actually very easy to do, with the exception of a few dual home Sun hosts. It actually worked very well. So we don't do unicast RPF just because of some technical issues that make that more difficult. We actually do a set of what I call static ACLs, but they are dynamically generated from our database. Okay, so maintaining these lists of prefix filters and these lists of anti-spoofing filters is extremely important, but it's also tricky. So how do we do that? We use an automated tool called IP Service. Now we've automated this for some time. Sorry, my cursor right in the middle of the word here. We've automated this for some time, but only recently have we created a more comprehensive tool that actually creates and maintains our both BCP38 access lists and also our prefix lists. And this is largely the work of Dale Carter, based on some dream specifications that I came up with years ago and actually wrote into a Google Doc, which he managed to find. This is sort of like good ideas, the old trash bin theory of good ideas. Eventually, two memos meet each other in a trash bin, and somebody finds them, and they're like, "Wow, this is actually a good idea." Not all the ideas I had in there were good, and Dale very kindly pointed out to me all the bad ideas that I had, and decided not to implement those. So he did implement some good ideas, plus he had a bunch of good ideas too, which he also implemented. And the tool that we created was called IP Service. It's a tool that's largely written in Python. There is a bunch of Jinja 2 templating that's done. And what it basically does is creates a set of JSON files that come from various databases. So our internal database, the IRR system, we may eventually pull in RPKI data as well, and also something called peering DB, which again, I'm going to talk about later in coordination and communication. You can see what happens. It actually creates a set of layers. So there's sort of a layered information that's done through various atomic operations. First, it'll create a JSON file, then it'll create a YAML file, then it'll plug that YAML file into Jinja 2 templates. That means that if we change routing platforms, it does currently drive the CLI, but if we decide we want it to use netconf, or if we want it to use something like Cisco NSO in the future, we can just simply plug that in to that layer. So it's actually very modular in the way it's designed. And this works really well for turning up new peers and also maintaining existing peers when they add or remove prefixes that they announce. This also, when I say peers, it's all types of peers. It's customers, it is transit, it is, like I said, we don't maintain the full set of access lists for transit, but we do maintain other parts of the configuration using this IP services tool. And it also works for just regular R&E peers and commercial peers. It automates lots of other things like our MD5 configurations, if we were doing TCP MD5 to protect our own BGP session, which is also a recommendation of MANRS. It's not necessarily a requirement, but it is something I recommend you do. And also GTSM, which is another way of protecting BGP sessions. Here's an example of just some stuff you can do with IP services. We can look up particular AS sets, and we can have it create JSON files for us regarding what, for example, what prefixes are registered to Google. If we have some time, I'll actually use the tool to generate an entire config so you can actually see what it does. So we have this service. This actually allows us to implement 2 of the 4 MANRS actions using a completely automated setup. And right now in ESnet 5, like I said, our existing version of ESnet, there's no orchestration involved. So an engineer actually triggers a IP service update or an IP service generation of configs for a new peering turnup. So it's not part of an orchestrated workflow at this point. That is something that will probably become part of ESnet 6, which is our next generation ESnet. We're currently in the process of transitioning from ESnet 5 to ESnet 6. And IP service is going to most likely be a big part of our routing automation in ESnet 6. And like I said, right now it drives the CLI. It will probably be driving some API in the future, or some API-driven configuration tool like Cisco NSO. Most likely NSO at this point. Okay, that's how we implement prefix filtering and anti-spoofing in MANRS. I'm also going to talk a little bit about policy invalidation. The way in which policy invalidation works in MANRS is it specifies a set of, for example, routing policies that you store in the IRR system. Michael Lambert already talked about how that worked, and also how you store prefix objects in the IRR system. He did a very comprehensive talk on that, which I've conveniently not linked from this talk, but I will add it to the slides before I send them out. So I'll put a link in about about Michael's talk to the IRR system, which many of you saw because it was in this very forum a few weeks ago. So policy invalidation. One of the things I will talk about at some length here is RPKI, because it's what Michael didn't talk about. And I want to speak a little bit about what we're trying to do with RPKI. I've talked a lot about what RPKI and origin validation can do. I gave a talk in Scenic that talked about origin validation in both the routing system and the naming system. So in the naming system, that means DNS and that means DNSSEC. And also in the routing system, that means RPKI and route origin validation. And here you can see the slides and the video of that. So some updates on what we're doing. ESnet actually now has 2 route validator caches, and they're running RouteNator 3000, which, not in addition to having a really fun campy name, is actually a very good piece of software. We've been running it for, I don't know, a few months now, and have had very little issues with it. It's running on 2 VMs. It's running on FreeBSD right now, and I like that because I like FreeBSD, but I also like the fact that we can run the latest version of the packages. They don't, they're not chintzy with how they support packages. So if somebody's willing to support the package, we can actually run the very latest version of RouteNator. It is written in Rust, and that is, it turns out, a very good language. It's very performant. It takes a long time to compile stuff in Rust, but it's a very performant language, and it's very robust in terms of how the software works. I've talked about the legal issues. Like I said, I'm going to gloss over those. We are working through some of our legal issues with Aaron. If you've ever heard me talk about RPKI, you probably have heard me mention the legal issues at great length, and I won't go into that much more at this point. There are other presentations where I talk about that in more significant depth, and I can refer you to those if you're interested. So how does RPKI actually work, and how does route origin validation work? Like I said, it's a PKI that's centered around the kinds of resources, basically the nexus between AS numbers that are originating prefixes and the route objects that they're trying to originate. And that includes IPv4 and IPv6 blocks and AS numbers. The RIR system operates the CAs, but there's no reason that you can't have other trusted CAs out there. It would sort of work like WebPKI, where you just have a preordained list of trusted CAs, and you can use other CAs. There is another CA out there called AltCA, which ESNet's resources are currently signed in. I don't know if AltCA is still operating because they are, there was temporary funding that was running them, and so it was mainly just a test CA. But it is kind of interesting to note that we could have additional CAs. It does not have to be coterminous with the RIR system, at least not from a technical perspective. And so you can also have a delegated CA that is delegated down from the RIR or whoever else owns the CA. That is, if you have a really big, if you're running a really big ISP and you're providing a lot of provider assigned addresses, that may be useful. It's not really useful for, it's certainly not useful for ESNet. It's not useful for a lot of RNE networks. We would just use a hosted version of the Aaron CA. So that's the other way to do it, is basically you just use a hosted version where you log into a portal, you say generate a ROA for this, and it will go ahead and do that. I'll talk more about RPKI validation because that's actually kind of interesting. The rows are fairly simple. It's just basically using a portal and generating the right rows. I'll talk a little bit about that later, and I should mention what a ROA is. It's a route origin attestation. That means that I am saying that this prefix should be originated by this ASN, so that if somebody who's not that ASN tries to originate that prefix, it will become invalid in the RPKI system. So the way you do this is you use a validating cache, which is just a regular computer running probably some Unixy operating system, a BSD or Linux, and you can run a validating cache. So a few years ago, I had these slides called the good, bad, and the ugly. The good was the fact that routers are getting really, really good at supporting RPKI validation. They will talk to a validating cache using now a variety of protocols. One is called the RPKI RTR protocol. Most vendor-supported routers like Juniper, Cisco, Nokia will talk to routers using this protocol. Free-range routing has an RPKI plugin, and they can also use things like RPKI over SSH or RPKI over HTTPS to talk to routers as well. The regular RPKI RTR protocol does not have any validation, so there's no public key authentication, there's no certificate authentication of the cache you're talking to. So you have to just basically trust the fact that within your network, you are able to route to the correct RPKI cache and not get attacked by a man in the middle. Again, using things like RPKI over SSH helps fix that. And also having the cache located close to your router and also having it firewalled off very carefully, that all helps improve the security of the validating cache. Okay, before, I would say about 2 or 3 years ago, I was saying this was the state of the software that you can use to validate RPKI to run a validating cache. There was a software that had been developed by Rob Austin and Randy Bush out of a grant that they got, and that grant expired and there hasn't been much going on with that since then. And then RIPE Labs from the RIPE community in Europe, they had a RPKI validator that was Java and it had like a ton of dependencies. I actually did try to run it. It's a real pain in the butt to run. So it got a lot better in the last 2 years. I mentioned Routenator 3000, that's written in Rust. That's what we're running. There's something called RPKI Client. That's part of the OpenBSD project, collaboration between both OpenBSD and NTT. Job Snyder's is helping at least do the specification of that, and the OpenBSD project is actually doing the programming. That's now portable. It's not just an OpenBSD anymore, so you can run it in pretty much any other BSD, or you can run it in Linux as well. And then Cloudflare has a set of tools that are written in Go. So we actually have 3 different languages, 3 different implementations, actually 4 different languages with the Java one, and 4 different implementations that are completely separate code bases. So there's good ecological diversity now in the route validation side of things. So how do you actually do it? You have to set up a cache. Once you set up the cache running the software I just mentioned, then you have to set up some sessions with the validating caches. And here's an example of how you do that. It's just a 1 command line really in Juniper. Once you do that, you're going to get a, you're going to download the database, provided that you've set up all of your firewall filters and everything correctly. And really the longest implementation part of this for me was fixing all the firewall filters that we had all over the place in ESnet. We do a lot of firewalling, we do a lot of filtering, both router ACLs and also full-blown firewalls. So for example, our validating caches actually sit behind a Palo Alto firewall. Whether it's going to stay that way or not, I'm not sure yet. We're going to see how that works. So, but here you can see that I picked an ephemeral port for this, and I put the validating caches into the Juniper configuration. Once you do that, like I said, it will download the RPKI database. You can look at that database. You can do show commands. There's stuff which I will show you in a minute how that works. But it doesn't actually do anything to your routing at that point. You actually need to create a policy to do that. So I created an RPKI validation policy. This doesn't actually drop prefixes. What it does is it lowers the local pref if the prefix is not if the prefix is invalid in RPKI, it lowers the local pref. So really, this is just a way of visualizing the data. What I do is I say if the validation database, which I've already downloaded from my cache, if it thinks that it's valid and that matches the route, and the way it says is validation database valid, if that means that the prefix is valid and the prefix matches the origin that it's supposed to have, then I mark it in the BGP table as being valid. And I'll show you how that looks in a Juniper in just a minute. If it's invalid,
one quick question, Michael, if you want to pause for a second. Daniel wanted to know on the previous slide, are those 2 lines supposed to be the same, or was that a typo?
Which one here? This?
Go back one more.
They're not the same.
Oh, yeah, you're right. There is one stanza that's
They have
different.
different IPv6 addresses.
Oh, okay. Yep, he sees it. Thanks.
Okay, so if it turns out that it's invalid, then I mark it invalid and I subtract 100 from the local pref. The other thing I could do is simply deny the prefix. And increasingly, the recommendation is if you are doing validation, since we are getting better at getting correct ROAs out there, that we should actually start dropping prefixes. The reason for that is if I just subtract 100 from the local pref, if the prefix that's being announced is from the wrong origin, but it's the same length as the correct prefix, that will work. I will not use that prefix to route traffic to. However, if somebody announces a longer prefix, doesn't matter what the local pref is, longer prefix is always going to beat anything else in routing. So because of that, the recommendation is increasingly being that we should actually drop the prefix. Since this is mainly being used as a test, I'm not doing that just yet. But we can go see, and I'm going to actually go show you some valid and invalid prefixes to show you what's going on here. Okay, here's the same configuration on a Nokia. I'm actually setting up the sessions like I did on the Juniper. Just, interesting Nokia configuration instead of Juniper configuration. Nokia will let you do a couple of things a little bit different from Juniper. You can certainly put the validation stuff into a policy, just like I did with Juniper. That works the same way pretty much in Juniper. Nokia will also let you do something like this, where you say enable origin validation at the BGP group level. What that does is it adds origin validation, valid versus invalid versus not found. It adds that not only into the BGP routing table, which is what I did in the Juniper policy when I said mark the origin validation as either valid or invalid, but it also puts it into the path selection algorithm. Admittedly, it's a little bit farther down the path selection algorithm than things like logopref. So I think it's actually past MED. But if you have a valid prefix, it will be preferred over an invalid prefix. So it does that automatically once you enable origin validation. But you can also add a policy which will actually have it deny invalid prefixes. Okay, so I'm going to demonstrate this a little bit here. Let's bring up some terminal windows. And I'll make this a little bit bigger. Oops. And we're going to go into some of our routers here. This is a Juniper. This is a Juniper MX104, so it's a pretty underpowered router. It's really slow and pretty crummy, but it does have a full routing table. If I just do show route, so the policy and the information that I had in the previous slides is actually been applied to this router. So if I just do show route on this router, you're going to see it's got about 830,000 routes, so it's got a full IPv4 table. It does have a static default, but you can see right after the static default, here's this 1.0.0.0/24, and you see here in the route table, it actually says validation state valid. So what you can see there is this is Cloudflare's ASN, and you can see that on Cloudflare's ASN, it actually says that actually is the correct ASN that's supposed to be originating that prefix. Now, a bunch of the other state just says validation state unverified. That's actually the most common in the internet, is to see unverified validation state. What I can do is I can show the entire database also. I think it's just validation, yep. And I can just say database here. And what it will do is it'll show me all of the stuff in the database and whether it's valid or not, basically whether the certificate passed the the cryptographic check that the validation cache is already done. That's whether it's valid there. Whether the route is valid or not is, does the prefix match the origin AS, and does it match the prefix and the prefix length? So in this particular case, you see 1.0.0.0, 24 through 24, which means that it basically, you can specify a prefix length range. It's increasingly not recommended that you do that. It's increasingly recommended that you specify the length of the prefix that you actually intend to announce, not specify a prefix length range. And then it matches the origin AS here. And this is the cache that it's getting the information from. Okay, now let's look at another route here. And I think what I'm gonna do is, I hope I can, I hope this still works. Maybe they fixed it. But let's try to show route. This is easy to remember, 1.37.137.0. Let's see what that shows here. I get that route. Okay, this is great, it still works. Here you can see validation state invalid. It is being announced by, originated by AS4775, and then it's coming through an upstream peer, and then through, this is actually ESnet's main backbone, and then this is the private AS where this test router is sitting. So why is that invalid? Well, if we look at our database, we can actually go down here and go down to 1.37.37. You can see 1.37.137, that particular /24 isn't listed here at all. 1.37.0.0 is, and it's listed with the AS of 4775. So it does have the correct origin AS, but it's not the correct length. This length is only allowed 16 through 17 for 1.37.0.0. So that's the covering prefix that includes 1.37.137, but it is not allowed to be announcing a more specific prefix. So because that more specific is making it into our table, our router's looking at it and saying, that's not valid because the ROA doesn't allow a /24 unless it's explicitly stated in one of these other ROAs here. This AS4775 is announcing lots of prefix ranges, which again, that is generally deprecated that you do that. Part of the reason is exactly what we're saying. It's easier to hijack a prefix if you do not, if you specify a wide range, and if you allow more specifics to be leaked into your table, it's actually a little bit easier to hijack that. So anyway, this is an example of what the table gives and what RPKI can give you. We can do basically the same thing on a Nokia. If we go to a Nokia router, this is sort of a QA router that we have that's in the ESnet backbone. And if, again, we look at, let's look at 1.0.0.0. And what you can see is, this is how the route came in. It does not have origin validation when it came in, so the router modified the attributes and applied the origin validation, again, because you can see here that it is doing the origin validation sessions that we had before. And again, if we do that 1.37.137, it's easy to remember here. And you can see here, origin validation says invalid at this point. So it is actually using that in its path decision. However, that's only part of the path decision. It's not actually dropping the prefix. It's still accepting the prefix. And you can see there is still a valid route to this prefix. I can do the same things here, like RPKI show. Let's see, I need to do this. And I can look at my RPKI sessions. Those are my two caches. And I can also do the same thing by looking at the database, just like you saw with the Juniper. And before you ask, I have not yet found out what that B flag means. I need to look that up. It's not documented anywhere that I can find it. So, so if anyone has a question of what the B flag actually does, I don't know yet. So anyway, that's how RPKI works in a router once you're validating. This is one of those things that I think it's sort of like having a browser that actually correctly validates in HTTP certificates. You don't have to sign all the certificates, although nowadays they're all getting signed and they're all doing encryption, but as long as you can validate a certificate, that's actually pretty important. Same thing with DNSSEC. I think we should all be running validation, and increasingly all of the DNS servers out there are running validation by default. And it's also the same thing with RPKI. The more of us that run validation, first of all, the more errors are going to be worked out. Cases like 1.37.137, which is probably a mistake, but at least those things will get fixed at some point. And it also means that we have, because more people are validating, more eyes are on what's going on with routing. It also gives more people incentive to create their own rows and do their own work to prevent prefix hijacking. Okay. So that is the validation part. The other part of validation is keeping the IRR system up to date, and also including things like route policies in the IRR system. And again, Michael did such a good job on that I'm going to pretty much gloss over that in the interest of time. In addition to communication, in addition to validation, there's also communication and coordination. I kind of mix those two in these slides here. But one of those things involves keeping PeeringDB up to date and using PeeringDB for generating things like prefix filters and stuff like that. I'll show you what a PeeringDB looks like. PeeringDB is a community-run system that is sponsored by a bunch of the big IXPs, Internet Exchange Providers, and also ISPs. And it's also used by a lot of participants. So here is the PeeringDB record for ESnet. You can just go to this record by just simply typing in as293.peeringdb.com, and it will take you right to our PeeringDB record. This is going to have really useful information like what our IRR record is. Again, this is something that Michael talked about, but the IRR record shows all of the ASs that ESnet carries. So if you want to build a filter with all of ESnet's prefixes in it, you can use a tool like our own IP services, or you can use a tool like BGPQ3, which is an open source tool that will actually allow you to generate prefix lists for Juniper routers, for Cisco routers, and for other routers using this kind of macro. So you can just type in BGPQ3 AS-ESnet, and it will generate a filter that will have all of ESnet's prefixes in it. So it's actually important to have that information publicly available. There's also contact information, and we do keep the contact information, which is now covered up by my helpful slide advancing mechanism. But if I hide from it for a while, you'll see the contact information right now is hidden. You need to have a PeeringDB account. You need to log into your PeeringDB account to be able to see the contact information, but it is something we do keep up to date. And it's also very useful because if you have someone that you want to peer with, or if you have someone that needs a lot of traffic, or has there's some latency issues or some troubleshooting issues you want to do, it has a list of all the public facilities where they are, and also the private facilities where you can actually maybe get a cross connect across from the Meet Me room and actually do a private peering with them also. So it's actually very useful just in terms of understanding peering policy, but also in terms of keeping all that information up to date. So we have documented what our peering relationships are and what we're doing. So that is the gist of the managed requirements. There are more aspects to managed requirements that we can go through. And there are things that everyone can do in order to help improve coordination, communication, prevent prefix hijacking, and prevent spoofing, I'm sorry. On your own networks, you can do things like create either ACLs or use unicast RPF to prevent someone from the physics department trying to spoof someone from the chemistry department, or someone from the physics department trying to spoof someone from Google. Either way, you want to prevent either of those two things, and that actually will really help. So if you're not already running unicast RPF, it's actually a really good, easy way to prevent spoofing without having to use ACLs. And you don't have to really automate it either, you just turn it on. In addition, Aaron has, this is different from the IRR system, but Aaron also has an origin AS field, which some ISPs and some dashboards will use to make sure that the prefix is actually being announced in the same, by the same origin AS that's actually registered in Aaron as the correct origin AS. So this is, like I said, this is different from the Aaron IRR. It's different from RADB and the other IRRs. What it actually allows you to do is specify in your regular Aaron record, so your regular IP allocation record, what is the origin AS right here of this particular prefix. And so other people can do that to validate, use multiple sources of data to validate that AS25 really should be originating this prefix. That's something that everyone can do. Everyone who has prefixes assigned to them, which includes pretty much all US universities, R&E networks, you know, basically anyone who runs a network can basically do that. In addition, you know, again, use the IRR system like Michael pointed out. Use the other forms of documentation systems, but make sure that you have your route objects correctly registered somewhere in some part of the IRR system. And that if you do decide to disaggregate, like your /16, you want to advertise a few /24s, you should do that by registering those /24s also in the IRR system. Increasingly, you will find that you can't get out to the internet if you don't do that. For example, Hurricane Electric will no longer accept routes that are longer prefixes than what's actually registered in the IRR system or in RPKI. It's either or both. In the case of Hurricane Electric, you don't have to be doing RPKI just yet, but you have to be doing at least IRR or RPKI in order to get your routes propagated through the internet. That's also true with level 3 CenturyLink and with a bunch of other NTT, a bunch of other providers now. And as we pointed out, because all of those providers are in fact now part of MANRS, they are doing those controls sort of by fiat of being part of MANRS. And that's one of the advantages of being part of MANRS, is that you can actually be knowing that everyone is taking these actions and make sure that there's a consistent set of actions being taken across the internet. Also, like, look into RPKI. Validating RPKI is something that a university can do, and you can also generate your own rows. Again, there are some legal issues around that you're going to need to look into, and you can find papers written about this. You can find other things that have been talked about regarding this. Make MANRS, by the way, make MANRS part of RFPs. If you need to sign up for ISP service, write an RFP or write a set of requirements, an RFQ, whatever, and say you have to support MANRS. It's one of the ways we can continue to make sure that it's just a very quick package. It means you're doing anti-spoofing, you're doing prefix filtering, you're taking all the due diligences, you're creating good route hygiene. That's basically what we want to be able to do, and that's why we have MANRS. You can just say, just one line, just say, are you implementing MANRS, yes or no? It's a very easy way to say, are you conforming to all of these requirements? And you can join MANRS. We have lots of EDUs, we have lots of research and education networks, and we have ISPs. It's also important, in addition to doing your part with RPKI and other cryptographic protocols like DNSSEC, and also doing things like HSTS on your websites, making sure your websites all have valid certificates, all that stuff. It's going to be belt and suspenders from here on out. We're going to need to implement lots of different ways of protecting our resources, and MANRS is one of those ways. There are also participation. There was a Scenic MANRS working group. I'm not sure if that's still active. I'm not sure if the IT routing group is doing anything, and I'm not sure what security groups are doing anything. So I'm not sure if there's additional participation that can happen in our community, but I'm very interested in hearing folks' thoughts on that. So I will end it there and take questions or comments, particularly on what's available for participation these days. I've been a little bit out of the loop because I've been working on the ESnet 6 upgrade and a big router RFP. So I haven't been doing as much in the community as I had been in 2019. So I will go ahead and look at the chat and see if there are any questions in the chat right now. And Jason, if you want to moderate the questions, it looks like all the questions have been answered so far. So are there any other questions?
Yeah, thanks, Michael. So certainly anybody, if you have any additional questions, please type them in, and I'll sort of echo what you ended with there. I know there's a couple people who are a little bit more active in Internet 2, either as employees or as members of the various working groups. So if there are active efforts there, please type them in and let us know. And I'll sort of do a poll the audience question as well. For those of you that do represent campuses or regional networks, who out there has implemented these procedures, who's thinking about it, who now after seeing this talk is going to think a little bit harder about it. You know, certainly if you want to protect your innocence or guilt, you don't have to answer, but that'll help us get a better understanding of who's out there supporting it and who's going to be doing it soon.
And while we're waiting for the show of hands, one thing I do want to mention in terms of doing RPKI validation, I talked about the legal encumbrances around the ARIN relying party agreement. That means even if you're validating ARIN routes, you have to sign an agreement with them. That is kind of hard to sign for some organizations. However, you can still run tools like RouteNator or RPKI client. It just won't validate the ARIN routes. It will use the trust anchor locators for all of the other RIRs. It just won't use ARIN's trust anchor locator. So you can actually still do validation even if you're not doing validation of ARIN routes. And I kind of anticipated that one of the people who would pop up here would be Andrew Gallo. And as I pointed out that Karen actually is, I did include them in my list of RNE networks that are registered with MANRS. And yeah, and I did mention CanREN as well. I will go back to that slide since that is what slide, like 3 or 4, I think.
Yeah, it was near the beginning. There was one quibble that Matsikoskis told me offline, is that I think you mentioned that Knox is run out of BU. I believe it is now run out of MIT, but I don't see anybody from Knox on, so no harm.
Okay, I think I thought I saw what looked to me like the Knox ASN in BU's MANRS record. So, but anyway, here are the ones I put in. Like, we could also go to the MANRS website and check it out. But yeah, so here you have a bunch of the regionals, and I know even some of the regionals that aren't listed here are still doing a lot of the same things now that MANRS requires, and it's just a matter of getting the certification done and the documentation done.
All right. Well, we don't have any others that are willing to put their hand up, so we'll imagine that you're all always doing this. Okay, so Jeff noted that Internet 2 is actively working with membership on IRR adoption. Let's see, IRRASSET for Internet 2's IP. Oh boy, there's so many letters and numbers, Jeff. I2PX service is now 97% of the aggregate routes advertised by participants. Okay, so that's pretty good. Okay, yeah, that's great news. So Jeff, I guess clarification, is this being done in one of the public working groups, or is this just something that's going on independently of those?
While we're waiting for Jeff to answer, I'll also say that we have a lot of the same issue that we will get national labs. We'll start announcing more specifics, and then trying to get those national labs into the, we're trying to get those more specifics into the internet and wondering why they're not happening, or wondering there's weird asymmetries. And it's actually because, not necessarily because ESnet doesn't allow it, but it's because the upstreams don't allow it because it's not registered in the IRR system. ESnet does have ways of allowing more specifics. to our sites, to various trusted sites, but we will, we can't control what ISPs do. So what often ends up happening is the ISP will reject that, as they should. So this is something that's very similar to what Jeff is experiencing with Internet 2.
Yep, and Jeff clarified routing working group and IRR working group, so that's good. So if anybody listening wants to participate, those would be the two public venues to do so. So I'll do a last call. Any additional questions, please type them in, and we'll thank Michael again for your time on this. Good stuff. And when I post the video, I'll make sure I put the links in the video and the email to Michael Lambert's talk as well as Pete's talk that sort of dovetail with this.
Thanks everyone for coming. It's always great to see all these, well, I didn't see that many faces, but familiar names on the screen there. Thank you guys for coming.
Yep. All right, well, thanks everybody. Hope you all have good weekends. We're going to have a Perf talk next week from Ed Cologne at Michigan. It's not going to be his students this time, it is going to be Ed, and he's going to be talking about Perf and Ansible. So please send that announcement along when it comes out if you have people that are interested in that. And we'll talk to everybody soon. Have a good weekend.